All right, so you found the quick review, and this is Algebra 2, and I'm going to talk about the discriminant. And the discriminant is the radicand of the quadratic formula, the b squared minus 4ac. And of course, you have to remember standard form to understand what the a, b, and c are. So the a is the coefficient of the squared term, the b is the, sorry about that, the b is the coefficient of the variable, the first power term, and the c there is the constant, right? And so by analyzing the value of b squared minus 4ac, we'll get an understanding of what type of solution we're going to get from a quadratic. And the reason is it's the radicand of a square root. All right, so let me show you the possibilities here. So possibility 1, when you put in the values of b squared minus 4ac, it's positive, meaning it's greater than 0. All right, so you get greater than 0 answer. Here's an example. All right, so b is a -7, but again, -7 squared is 49. So there's b squared, and then a -4 times the a be a 1, so that's -4 times 1 is -4, times a +2, so -4 times 2 is a -8, and the value of the discriminant is 41. So here's an example where the value of the discriminant is positive, right, or greater than 0. And so here's the reality with this. What kind of solutions are we going to get? Well, we're going to get two real number solutions. And we can further clarify that. If this number ends up being a perfect square, 1, 4, 9, 16, 25, etc., remember that's a root. And so in that case, then it's going to be two real rational solutions. If this number is not a perfect square like it is here, then they're going to be two real number solutions, but they're going to be irrational. Okay? So perfect square, two real rational. Not a perfect square, two real irrational. The discriminant. Second scenario. Well, you can have it equal 0. b squared minus 4ac might actually equal 0, in which case you're taking the square root of 0, and the square root of 0 is 0. So guess what happens? If you look back up at the quadratic equation, plus or minus 0 means nothing. There's no plus or minus fact at all. And you really get one solution. So in this example here, again, we're going to go b squared. So -8 squared is 64. And then minus 4ac. So -4 times a 2 is a -8. And a -8, this should be a positive here. And a -8 times a +8 is a -64. And that's the example I want to give you a 0 discriminant. So in this case, when you go to take the square root, it's going to be the square root of 0. And instead of having two real number solutions, you're going to have one real number solution. It's just going to be one real number. If you solve this by factoring, both factors would be the exact same factor and yield the exact same root, and hence you only get one. Okay? So the discriminant. Third possibility, okay, so hopefully you can figure it's either going to be greater than 0, meaning positive. It's either going to equal 0, or it's got to be what? Less than 0. Okay? Meaning, again, it's going to be negative, right? What if the discriminant is negative? So here's an example of that. So again, let's do b squared. -2 squared is 4. Minus 4ac. A -4 times a 3 is a -12. And -12 times a 1 is a -12. And notice we end up here at -8. So what happens when if this -8 were actually in the quadratic equation, you'd be taking the square root of a negative quantity, and you should realize that that's a complex number. So here's what we get in this case. We get two complex conjugates. With complex numbers, you always get conjugates. And again, what does a conjugate mean? It means one's the positive and one is the negative. Let me give you an example. It might look like this. 3 plus the square root of 5i, and usually you put the I in the front, and 3 minus the square root of 5i. There are two complex roots. And a lot of times we could write it together. It could be something like this, -7 plus or minus 2i. So there's -7 plus 2i, -7 minus 2i, two complex conjugates. All right, the discriminant.